down last 2 days, but I was my day totally occupied, so I couldn't be able to training. So now, students, I'm going to solve it out, right? My kids. So student, now I'm going to solve this is in idea that is questions number 19. Right, Peter? This is questions number 19. I'll read question once here. A particle is moving along with x-axis whose position is given by. Okay, along, I'll read the questions here and we'll also work with I'll read the questions in the solution here. This is the given, my dear. This is given. This is your x is equals to 4 minus 90 plus EQ3. Mark the correct statements in relation to its motion. Right. So, beta, what is the first option? Direction of motion is not changing at any of the instants. Option first. Second, my kids, direction of motion is changed at t is equals to 3 seconds. Options number Bombay, my kids, Canada, for 0 less than 0 less than t greater than 3. Uh, that is the particle is slowing down, and last my kids, for t greater than 0 and less than 3 the particle is speeding up. So this is the question, my kids, right? Okay, so now my dear, I'm going to solve this question here. I'll solve these questions quickly. You can get idea of this question. So beta, this question is nothing yet. It's, I can say, basics of basically beta. If you are pretty well about the concept of differentiation, so definitely it's you can solve this questions. No worries, right? So students, for this condition, I can say, beta, this is I'm going to start just a solution further. Okay. So what my kids? This is their basic mention. So simple beta. We have to just comment what is the velocity, acceleration, and all. So simply beta, in step one for these questions, my kids, I hope you remember here. If x as a function of t, if you will differentiate once, if we have beta x as a function of t, if you will differentiate once, you will get velocity. If you will differentiate more than one time, then you will get what? Acceleration. I see there these questions in classroom, normal class. So now kids, I'm going to differentiate one time. So I'll write v is equals to, my dear, this is dx by dt. V is equals to what, my kids? Dx by dt. Right. So here beta, right here, what is x is mentioned? So this is a differentiation of 4 minus its 90 plus tq by 3 entire bit as dt only. Beta, first for your convenience here, you can just open entire bracket, more easy for you to understand. So this is beta, I guess, the differentiation of 4 upon beta z dt minus 9 beta, I can take it out here, it's a constant, my dear. 9, this is differentiation of dt upon dt plus beta. You can again you can take beta 1 by 3, keep it out. Differentiation of d3 upon dt. Done, my kids. Now beta, I can say, as you know here, differentiation of any constant terms. My kids, differentiation of any constant terms will goes to 0, right? Beta, differentiation of dt by t here, you can see, becomes 1 only. So you can write beta velocity is equals to minus 9 plus 1 by 3 beta, as usual here, constant, so no need to worry about that. Differentiation of TQ by 3 beta. Once I'm writing beta formula here. This is what differentiation of x to the power n upon dx. You can write it. This is n into x to the power n minus 1. So, my dear student, I'll apply this formula, right? Beta, I'll apply this formula, my kids, to get answer of this differentiation here. So, you can see simply this is 3 t square. Or beta, you can see 3 t square. You can see this is what 3 beta cancel here. So finally, can write with V is equals to minus 9 plus beta z t square. Now beta, according to these equations, you can come in speeding, I can say velocity or whatever the particle are speed up or down, right? My kids, here you can write beta for this condition. We'll go here option number first. What's option first here, beta z? What option first is here? Direction beta. Now just I'll discuss it one by one. So this is my kids. I can see options one. I'm writing my dear. Right. In options one beta, what they mentioned. Beta the options ones, what they mentioned. Direction of motion is not changing at any instant of time. So this is wrong, my dear. Yeah, once it will put t is equals to 3. So velocity will become 0. So beta option first is what? Wrong. Option first is what? Wrong. Right, my kids? Okay. Now here we have to talk about, I can say options number Bombay. Options number beta, what you can say? Bombay here. So what about options number Bombay, kids? Direction of motion is changing at t is equals to 3 seconds. Absolutely correct, beta. Perfect here. What they say at t is equals to 3 seconds. At t is equals to 3 seconds. Beta, what means my kids? Direction of motion is changing. True here only. True, beta. This is correct. How my kids? Simple, beta. This is, let us say, equations number 1, beta. You can write here v is equals to minus 9 plus t square. You can fit beta here. T is equals to 3 seconds. T is equals to, my dear, this is what? 3 seconds, right? So it will get here velocity is equals to 0. So we can see beta, sir, options number Bombay is correct. You can see beta as options number Bombay is correct, right? Okay, now beta options here. What option says? Option C beta they mention here. What they mentioned, students, options number C. Beta, listen carefully. For G, they can say it's greater than 0 and less than 3, right? Uh, the particle is slowing down. Okay. What bacha they mention here? The particle, the particle is slowing down. The particle is slowing down. Beta, we have to solve here. So now kids, you can simply say here, these questions. Beta is the not a tough questions there. I can see logically it's a strong questions. Beta I can feed here in these questions. Let us suppose beta in equation 1, first beta I can put here. T is equals to 0, right? So you can see sir velocity is equals to what, my kids? Velocity is equals to, you can write beta velocity is equals to, you can write this is what? Minus 9. This is what? Minus 9, right, beta? Okay. Now, beta, I'm going to put here, putting that is t is equals to beta g 1. Students, now I'm putting here t is equals to 1 in equation number 1. Again, you can say, bacha, sir, velocity is equals to minus 8. Again, here, next, you can say, bacha, ji, let us suppose you can say here t is equals to 2. So 2 to the 4, yeah, 9 minus 4 beta. What you can say? velocity is equals to minus 5. So what you can write beta G for this question here? Yes, this is option C, dear, also correct. For t greater than 0 and less than 3, the particle is slowing down. Absolutely correct. No need to worry. So beta, I can say options number B and C now correct beta. Now my dear, have a look next year. I can see last option D. What options D beta telling here? Have a look. Beta they mentioned here t greater than 0 and less than 3, the particle is speeding up. Absolutely wrong here. Absolutely beta option D is wrong, not kids, sir. Because if option C is possible here, so D is not possible at all. So you can see what's a party. This is what option D is incorrect. Option D is incorrect. Beta, for this question, which option is correct here? Only Bombay and Canada. Only Bombay and Canada. I hope beta your doubt has been resolved. You can watch here anytime because now I'm just making live sessions so that maximum students can get benefit here. 11th class it's crucial time beta to understand differentiation. If you are very good in differentiation, you will enjoy entire physics. If you are good, very good in integration, you will enjoy entire physics. If you have a doubt in integration differentiation, let me know, my dear. Now, students, have a look here. I can say next. That is what my kids. Which questions, my dear? Which you said me? Just give me seconds. I'll check. Okay, that is students of questions number 5 to here. Okay, now students, I'm going to solve my idea. That is, I'm going to make solution of it. That is questions number 5 to right. Okay, fine. So have a look, my kids. Okay. So this is what we do. Now I'm going to make a solution of questions number 52. Right. Okay. So beta, what is the questions 52 here? Beta, I'll read your question once. Okay. Uh, velocity of a body is moving along a straight line with uniform acceleration A reduces by 3 by 4 of its initial velocity in time t naught. Full stop. The total time of motion of the body till its velocity becomes zero is. Okay, my kids, there are four options, right? So, beta, listen carefully here. It's not tough questions at all. I'll make a diagram of this question first. My kids, listen carefully. Beta, what is questions here? You can beta try to understand. Focus on lecture only. Beta, now I'm going to make solution of, I can say, this is questions number beta kids 52. What question says here? You can say this is what straight line path. A constant here. I told in the classroom there are two possibilities of path. So now here this is only motion, so no worries here. Path must be straight line only. Now students, let us suppose this is what your initial point. I'm calling here at this is point A. You are at here. This is point B. This is the last point here. Point C. Listen, kids. I can see beta carefully. A, B, and C. Beta, what they mention here, let us suppose I'm telling you, beta, initial speed of particle. I'm considering this is what you can say U naught. U naught is what, my kids? Initial speed of the particle. Beta, what mentioned in the questions, I can say if particle has been traveled, my kids, if particle has been traveled, beta, how much? This is beta t naught time traveled. So velocity we have mentioned here that is reduced by how much? 3 by 4. So we can write here at this point velocity. Beta, I'll write here carefully. Listen. Velocity at point A, beta, I consider that is what? U naught. Now, beta, I'm finding that velocity at point B. According to questions they mentioned here, they reduced 3 by 4 of initial. So, beta, what is initial here? Initial, you can say beta as the U naught, right? What is the final? They mentioned already, my kids. 3 by 4 of initial, right? So here you can write the velocity at point B, which is equals to, you can say 4 minus 3 here. So which is equals to U naught by 4. Which is equals to U naught by 4. Beta. This is the condition here, so keep in your mind. Now students, basically mentioned in the question, acceleration is what? Constant forever. So students, this is I can say what I did here. You can take as a consideration in step one what I have done, right, beta? Okay. Now students, I'm going to solve further this question. This is the part of I can say step two, which is what my is part of the step two. But now here I'm going to use students equation number what one, because beta we have a three laws of motion. First beta v is equals to u plus at. Second my kids s is equals to ut plus half at square, and third what you can say v square minus u square is equals to 2as. My kids, you can apply this formula anywhere if acceleration is constant. In this question, my kids directly mentioned here acceleration is what? Constant. So you can write Vachaji. You can write students. I'm applying equations number one here. So what is equation number one? This is V is the final velocity, U is the initial velocity, A into T, and A is what my is acceleration. A is what my is acceleration. Okay, beta, at a point here we found this is the final velocity, which is equals to my kids U naught by 4. So we can write student this is U naught by 4. What is the initial velocity here? That is what we consider from our side. So you can say this is remains U naught plus you can say bacha A into T naught. T naught mentioned here because this particle once arrived over here, what is the time here? T naught only. So here from beta this equation will get acceleration value. My kids from this equation will get what? Acceleration value here. So beta just separate here left and right. So we can see this is what my kids u naught by 4 minus u naught is equals to a into t naught. So we can say, bacha, this is what minus student you can write minus 3 u naught by 4 upon beta g t naught, which is equals to acceleration. Now beta, uh, I found acceleration value here, which is remains constant forever. Which is remains constant forever. Now, student, in this questions here, what they say. Now, beta, I'm going to solve further of these questions, which is the part of my kids. I can say step three. Right. Beta, now here I'll discuss further. Beta, I can see remaining portion here, B to C, because what they asked in the questions, you need to find total time. Now, students, I'm going to make here one more diagram. So, beta clarity, you can say, beta, this is point A, this is point B, this is point C. Beta, I can see for AVR, timing already known for us, which is equals to T naught. But I don't know timing here B to C. So, but now I'm telling kids this is what basically T1. This is what basically T1. So, beta, in this question, we have to find what is the total time taken by particle from point A to C. So, here I'll find T1 and then beta I'll add T naught and T1, then we'll get your final time. Right? That is the question, my kids. So, here, beta, I'm going to apply again equation of motion what? First only, right? But I'm going to again apply a equation number first, but there is condition. But previously I applied equation of motions A to B. Now beta I'm going to apply equation of motion for B to C. So this is what my kids for B to C. For my dear B to C, right? Okay. So bachas, again here I'll use my rule, that is equation of motions first only, because number we can apply anywhere if constant remains here. So you can say this is V is equals to U plus A. So beta, once your particles finally arrived at point C, mentioned in the questions here, velocity will be zero. Velocity will be zero. So you can say, well, sir, final velocity of the particle will be zero. Now, beta, at point B, we already found what is the velocity. So we can say at point B, velocity towards the right direction, which is equals to u naught by 4. Which is equals to my kids, u naught by 4. So this is zero here. Beta, already knew what is the velocity here, so you can write over here. This is u naught by 4, and acceleration is already found in, I can say, step number 2. So now, beta, I'm just going to use here. I'll substitute, beta, I guess the acceleration value from step 2. So minus student 3 u naught by 4 into beta z t naught, right? Yes, correct, sir. This is what I'm calling a T1. T1 I wanted to find. So finally, beta, I'll equate both of these here. So you can say, sir, u naught by 4, which is equals to 3 u naught by 4 into my kids T naught into T1. T naught into T1. You can say which that is what U naught and U naught cancel. 4 and 4 cancel. So you can write with party. This is T naught by 3 is equals to T1. So now here, finally I found the time taken by particle to travel B to C. Now, the last part of the questions here, what they ask, beta, they ask in this question, they ask where they ask the students what is the total time for entire journey. Velocity becomes zero. Which is students, I can say step here. This is 4. So students, you can write total time. You can write student total time, which is equals to students, you can say t naught plus t1. So this is what students, you can say our t naught itself, t naught only t1 here we found in terms of t naught. So you can say this is what t naught by 3. So total time beta, you can say this is what 4 by 3 t naught. What my kids? 4 by 3 t naught, right? So beta, which option is correct here? I'll see once. Option. Okay. Beta, I can say option first is correct, beta. My kids, option first is your correct answer. My kids, option first is correct. Option first is correct. Okay, fine, dear. So I can say further, everyone. Okay. I can see, beta, God bless you are those still in the night around 12, 11 minutes past 12 o'clock, beta. You are just still watching here. Yeah, God bless you. Stay tuned for this one, beta. You will get benefit here of physics point. Okay. Now, students, I can say here, what's the next question, please? Have a look. Okay. Which is, I can say, next question, my kids. Questions number 49. Right. Now, students, questions beta, I'll see this is questions number 49. Yeah, just I'm making better position here so that it's will help you out a lot. So now, students, I'm going to make a solution of questions number beta 49. Questions is what I can say beta the 49 here. So what questions is that? I'll just read once questions entire, right? Okay. So beta give me seconds. Allow me. A police party is moving in a jeep at a constant speed v. Okay. Beta, I'll be diagram beta along with the questions. Students, let us suppose this is what track of road. This is what track of road, right, my kids? You can say, sir, there is a, I can say police jeep, right? This is the police jeep, and I can say, bacha, who is another one here? Thief. So you can say, bacha, thief. If I can say he is driving a motorcycle. So here I'll make a diagram of motorcycle, Vitaji. Okay. So now, kids, let us suppose you are here. So now, beta, this is jeep and this is a motor cycle. But I'll repeat question once again here. Police party is moving in a jeep at a constant speed v. Okay. Beta, your jeep is in motion, which is moving with constant speed beta, which is v. Just keep in your mind. Okay. They draw a thief at a distance x on a motorcycle. You can say, bacha, what is the distance between because a students distance between I can say thief and motorcycle that is mentioned my kids which is equals to x, which is equals to x, right, kids? Okay. Uh, which and now beta mention here. Motorcycle is what beta? This is mentioned over here. Motorcycle is at rest. Motorcycle is at rest. Beta, what mention here? Motorcycle is at rest. Okay, fine. Now, students, further what says? The moment the police saw the thief, the the thief started at constant acceleration. Okay, you can say my kids, thief started here at constant acceleration. Let us suppose I'm taking direction in rightward. This is what we mentioned, students. This is alpha. Yes, beta. Alpha meter per second square. You can take like that. Alpha beta, you can say meter per second square. Okay. Now, beta, what we wish to find here? Which of the following relation is true if the police is able to catch the thief? Okay. So, right option here because option is very easy. This is what my kids option first says v square less than alpha x. Now beta see Bombay v square less than 2 alpha x. My kids Canada that is v square greater than 2 alpha x and Delia forever green that is what my kids v square is equals to alpha x. Done here. That is part of the question my kids. Now, beta, I'm going to solve here. This all things what I drawn, beta, what I have written, that is a part of question solving. Beta, you know what is the I can say Raman for this kind of numerical? Listen, Bachasi. What is a Raman that I can say for this kind of numerical? That is the first point. My kids, keep in your mind. If if in a common question, if there are two objects, so always think about relative ones. concept. My dear, always think about relative concept, right? So, beta, here I'll apply relative concept of velocity as well as relative concept of position vector as well as with a relative concept of acceleration, right? So, beta, first here I'm going to solve beta these questions in solutions case. In solution case, this is step one. This is what my warrior say one, right? What's the point velocity of relative velocity because so this is what velocity of because I can say zip jr with respect to motorcycle. I hope all of you remember here. Other than writing velocity of A with respect to B, velocity of A minus velocity of B. What implies here? We can say this is in motion and B is at rest. That is meaning of velocity of B. Velocity of A with respect to B. So here, students, I'll write here velocity of I can see G minus beta G velocity of motorcycle. The question itself mentioned here, so no need to worry. Velocity of g beta, that is your motion with constant b bacha party, right? Now students, you can see here what is the velocity of beta I can see for motorcycle here, that is remains zero bacha, mention my kids in the question itself. So you can see this is what we only. Okay, my kids, I'm going to apply next formula. That is what my worry is. Acceleration of I can say zip with respect to beta z motorcycle here. So you can write my kids acceleration of zip minus beta z acceleration of beta z motorcycle. Right. So here in the question mentioned here, zip is in motion, but beta not accelerating here. So you can say acceleration of zip. What you can take beta? That is zero. Minus what is the acceleration of motorcycle here? That is means alpha. So you can say minus alpha. So what is the relative acceleration, my kids? Minus you can say beta z alpha, right? Beta unit here I'm not taking here. Already understood it's a meter per second square beta g. And every unit here nothing mentioned. Then you can take as a consideration. Yes, I with my kids. Now beta I'll apply here concept of relative position. Right. So you can say beta concept of relative position you can write. Oh, someone beta God bless you. Oh, someone wrote Hare Krishna. Now, students, hello. I can say student. This is what position vector of beta, right? Expression of jeep with respect to beta motorcycle here. So you can say position vector of jeep minus beta position vector of motorcycle. So what is the position vector here? That is mentioned, bacha, body because this is initially traced here. So you can say, bacha, what is this here? You can say x minus 0, which is nothing here. You can say remains x. Now, beta, simple here. We can apply further formula which are everything we got here because acceleration constant, we got relative velocity vector party. So now my kids you can apply. Now further, I'm going to solve my kids, which is step 2 of this question, my dear. Right. So again here, I'll apply here my kids equation of motion third. Right. So what is equation of motion third here? Tell me. This is you can say v square minus u square, my kids, 2as. V square minus u square is equals to 2as. What is v bacha party? Tell me here, what is v? Beta finally zero ne yaar. So you can say this is what? Zero. What is the beta relative velocity here? That is what v only. So you can say bacha this is what? V square. Now, beta, I can say this is twice and what is the relative acceleration? Which is equals to my kids alpha. And what's the displacement here? That is we found a relative position. This is what x. You can say is minus and minus cancel each other here. So you can write v square which is equals to 2 alpha x. Means beta which option is correct here? Okay, V square is equals to 2 alpha F. Right, beta? So you can say here, this is the condition which you can also write here because there is no option at all. So beta, this is greater than and equal to here. So students, you can go options number here, Canada. Canada is correct answer for these questions. So kids, if you have a doubt here, you can drop me here, right? I'll tell you solution as soon as possible. God bless you, those who join, those watching me in the night, 23 minutes past 12 a.m. God bless you. Now I'm going to start my session. All the very best. Stay happy, stay calm, be positive. You'll get everything which you wanted.